Hello, we're going to discuss measures of association today. This is an empirical study about various kinds of variables that is being targeted and the effect of one of the variables with contingency plans under inclusion principle regarding the other variable. If one of the variable is given to us and we know the concept of the dependency factor that will creep into the organization mind. It's about concluding what is going to be affecting one of the variables if the other variables is kept on changing. Because of a change in one of the variables, for sure, if there is a measure of association, if there is a dependency factor, the other variable is going to change, going to be affected anyway. Statistics includes such kind of references. These references comes from the association of the attributes that can be defined, that can be arranged to include that one factor over a long period of time is going to have a certain kind of impact on the other factor. Statistics is all about describing and making assumptions about the attributes and inferences about a single distribution, and that is known as univariate statistics. Univariate statistics form the basic basis for many other types of statistics. Some of the issues concerning relationship between variables can be answered only by examining more than one variable. So a single variable, by observing a single variable, we are not going to conclude anything because it will not have, and it is not likely to have any impact on the other variable. In order to examine the relationship among variables, it is almost necessary to move to at least the level of variable and bivariate statistics. Frequently, the researchers wishes to move beyond the multivariate statistics, where the relationship among several variables are simultaneously examined. So we are concerned about the effect of one variable changing over the other, and if that is correct, if that is assumed to happen, then we should be in a position to calculate the value of the second variable given the value of the first and the dependent variable. Bivariate, both the bivariate and multivariate statistics are useful not only for the statistical reasons, but they form a large part of social science research. Research into psychology, research into education, research into healthcare. The social science is concerned not about fulfilling the expectation of social phenomena, but this necessarily involves testing for relationship among variables. For example, amount of rainfall, monsoon causing an impact on agricultural output in India. Monsoon doesn't have the same kind of effect on agricultural output in Europe because European countries are not dependent upon monsoon and its fluctuations regarding rainfall. Unlike in India, when majority of the rainfall happens during the monsoon season, European cities, American cities for that matter, they get rainfall more or less throughout whole of the year. So social phenomena just don't happen. There is cause and effect relationship that will be going into the factors. In looking for those cause and effect relationship regarding the causal factor and attempting to determine which variable is going to cause an influence over the other variable is going to be the most imaginative activity. The researcher has the has to find the cause and effect relationship and must establish the nature of relationship that is going to exist between different kinds of variables. Variables that appear to have very little relationship with another variable that one of the researchers is attempting to explain may be ignored. This can happen because of the bias that is happening. Variables which appear to be related to other variables being explained must be closely examined. They can be undertaken in different perspectives. If we want to establish a particular kind of relationship between the profits earned by a corporation and the amount of sales done by the corporation, then we must do it not for 1 year. We must do it completely for 2, 3, 4, 5 years. That is when you are in a position to establish the cause and effect relationship. The cause and effect relationship is not to be loosely derived, must exist for a certain period of time. That is when you are going to conclude that they are true and they are happening again and again. The researcher is not concerned about whether the relationship exists or not. If the relationship appears to exist, then the researcher wishes to know, he has the tenacity to understand what kind of relationship is there. What is the nature of the relationship that is exactly going to be in existence. The size and strength of the relationship is of primary and utmost concern. And there are various tests concerning these measures. The measures are important. What kind of cause and effect relationship you are trying to establish, whether it is a correlation or a regression, whether you're going for explaining a t-test or through a z-test. What is the rationale behind all these kind of tests? One of these measures is measures of association. Overall, we're talking about the relationship. Some of the associations, some of the factors, they will be in a position to conclude the degree of association, how something is related to other thing. If they're positively moving, for example, the number of hours a student is putting into study must be directly proportional to the number of marks he is fetching. So measures of association provides us a means of summarizing the association, kind of association, type of association, degree of association between the variables. Most measures of association are scaled so that they reach a maximum numerical value of 1 and a minimum numerical value of -1. When the numerical value of measures of association is 1, then the variables has a perfect relationship with each other. But they are also scaled so that have a value of 0, which means absolutely there is no relationship existing between the variables. There are always going to be certain exceptions to these rules. Most measures of association are of this sort. Some measures of association are constructed to have a range of 0 to 1, and others are constructed to have a range of -1 to 1. When the range is starting from -1 and going on till +1, it provides a means of determining whether the two variables have a positive or negative association with each other. So measures of association is trying to construct, trying to bring out any kind of relationship that can happen between two kinds of definite variables, one being independent and the other being dependent. Tests of significance are also provided for many of the measures of association, which can be calculated with the help of given sets of numerical data. These tests begin by hypothesizing that there is no existence of relationship between two variables and that measure of association equals to 0. The researcher in that particular manner calculates the observed value of the measure of association and if the measure is different enough from 0, then the test shows that there is a significant relationship existing between two variables. So measures of association can be concluded from the tests that we conduct in that process. There are various kinds of types of associations, one of them being the positive association. Positive association, when two attributes to variables A and B are said to be positively associated, if there is the presence of an attribute is accompanied by presence of the other. For example, health and cleanliness are positively associated attributes. It is commonly believed that if a person is clean, a person is keeping track of his requirement of health, his clothes, his medicine, his foods, he's not consuming junk foods, he's not consuming foods which is not suited to his personality, which is not suited to his requirements. The balanced diet, overall cleanliness in the house will keep his health in a better condition. So these attributes are particularly related to each other in a positive manner. But in the same way, two attributes will be said to be negatively associated if the presence of one ensures the absence of the other. If somebody doesn't bath, somebody doesn't use a soap for cleaning purpose, whether his own body or his clothes, for 1 month. When somebody doesn't take care of the activities, physical activities, you're walking, you're sitting always, you're watching too much TV, you're completely submerged in your laptop, internet, emails, so you don't have any chance of indulging in a physical activity. So there is an absence of a balanced life that is going to negatively impact your health. Otherwise, you're going to gain weight, you're going to gather some kind of illness like gaseous substance. There is a negative association. Similarly, two attributes are going to be defined independent if the presence or absence of one has nothing to do with the presence or absence of the other. For example, a guest coming to my house, I'm not affected by his presence, I'm not attached to him, I'm working the same way, same manner that I have worked three days before he arrived. Likewise, my food preferences has not changed. I have not made any kind of arrangements whatsoever for his benefit. I'm going at the same time to office and coming back at the same time. He's on his own. So these are independent factors, two attributes which are not completely, which are completely independent of each other, one not having any relation and neither they're not having any relation. So the presence or absence of one doesn't make absolutely any impact with the presence or absence of the other. The methods of measurement of association can be done by frequency method, proportion method, and Yule's coefficient. There is also the fourth method, Yule's coefficient of colligation. The first method is frequency method. In this method, we compare the observed frequency of adjoint classes for attributes. The two attributes A and B is given with their expected frequency, and we have to calculate the expected frequency from the observed frequencies. If the observed frequency is greater than the expected frequency, then the association is positive. If the observed frequency is less than the expected frequency, the association is negative. In case the observed and expected frequencies are almost identical, then the two attributes are independent of each other. The main drawback of this method, the frequency method, is that we cannot find the degree of association even if we are able to find any association, it is one kind of association, whether it is positive, negative, or independent of each other. We don't know what kind of one degree of association the variables are having. Given the following data, find out whether the attributes A and B are independent, positively associated or negatively associated. A is given to be 15, value of B is given to be 15, A multiplied by B is 15, N is 50. We find A into B by N, the expected value to be 15 into 25 by 50, that is 7.5. AB is 30, which is greater than 7.5. We follow the following principles. A into B must be greater than A into B divided by N. If this happens, that AB is greater than A into B divided by N, then there is a positive association. If it is less than, there is a negative association. Because AB is 30 and it is greater than 7.5, there is a positive association between A and B. So we conclude that the expected values are less than the observed values. So observed values are in positive relationship with the expected frequencies and expected values. We have taken another example. Given the following data, find out whether the attributes A and B are independent, positively associated or negatively. A is given to be 130, alpha V, which is the opposite of 1 minus A, is 180, alpha is 240, AB is 430. We follow the following principles, that A plus alpha is N. If N is equal to A plus alpha, A and alpha is given, so N is 310 plus 240, that is 550. AB plus alpha V is B, which is 430 plus 180 is 610, so B is 610. So our observed frequency is A into B by N, 310 plus 310 multiplied by 610 by 550, that is 343.8. AB is given to be 430, which means AB is greater than A into B divided by N. It means A and B are positively associated because they complement the principle that AB must be greater than A multiplied by B divided by N. So these values are positively associated and are dependent upon each other. The next method is proportion method. Two attributes A and B are said to be associated if the proportion of A's in the B is the same as amongst betas. Also, if the proportion of betas, then there is a positive association between A and B, and if less than that, A and B are negatively associated. We can summarize them. If AB by B is equal to A into beta by beta, then A and B are independent because they are almost identical. If AB by B is greater than A into beta by beta, then A and B are positively associated. If AB by B is less than that of A beta by beta, they are negatively associated. Equal, independent, greater, positive, and lesser, negatively associated. Still, there is no confirmation about the degree of association. In the proportion method also, we fail to find a kind of association. Rather, we fail to find the degree of association, even if we are able to ascertain the kind of association, positivity, negativity, or independency. For example, in a study of 200 persons, 120 are poor. Out of 100 persons who suffer from TB, tuberculosis, 50 are poor. Find the kind of association between poverty and TB. Suppose A represents the attribute poor, A is 120. B represents the attribute of TB, that is 100. Total number of observation is 200, and AB is 50. Poor people suffering from TB. We can summarize the two-way table as A is 50, the happens in the B, AB. So alpha, which is not A, the total number of TB patients are 100. So total minus alpha, total minus B is alpha, 50 again. A plus beta is 120, so beta is 70. Alpha plus beta is 100, so beta is 30. So which means we have to calculate all the three. AB by B is 50 by 100, that is 0.5. A beta by B beta, A beta by beta, 70 by 100, that is 0.7. So you can see clearly that AB by B is A beta by beta. The relationship is that AB by B is much lesser than that of A into beta by beta. 0.5 is less than 0.7. So by the rule, A and B are severely negatively associated. They are in no way positively or independent of each other, which means if one of them happens to be increasing, the other's value is going on to decrease. The next methodology is Yule's coefficient, which is the most popular measure of association. The main advantage of Yule's coefficient is that it not only tells about the kind of association, but also the degree of association. So this is the first coefficient of association, which is providing us the degree, the kind of association that we have. For two attributes A and B, the class frequencies can be displayed in a two-way table, that of the proportion method. A and B, then beta, AB, alpha B, A beta, alpha beta, and BB, A alpha and N. Total is A, total is alpha, and total is N. We can summarize that in a question format. For the cell frequencies given above, the coefficient of association can be calculated as Q. Q is AB into alpha beta minus A beta into alpha beta divided by AB into alpha beta plus A beta into alpha beta. The value of Q lies between -1 and +1. If the value is greater than -1 but less than or equal to +1, there is a perfectly positive correlation. If Q is exactly -1, this is perfectly negative association. If Q is 0, two attributes are completely independent of each other. We prepare the two-way table for the frequencies with two attributes A and B. If we are given that N is 100, N is 800, beta is 330, A is 420, and AB is 110. We can summarize that. AB is 110, beta is 330. So if beta is 330 and we are also given AB is 110, so which means out of 800, if you discount beta, then the first column, first row total will be 800 minus 330, that is 470. If you find AB to be 110, then alpha B is 470 minus 110, that is 360. Then out of 420, if you minus 110, you will get beta is 310. So A beta is 310 and alpha beta is complementing, it's 20. So by putting all these values, Q is equal to AB into alpha beta minus A beta into alpha beta divided by AB into alpha beta plus A beta into alpha B. 110 into 30 minus 360 into 310, 110 into 30 plus 360 into 310. The value is coming to be minus 0.94. The value shown is falling between -1 and +1. This shows that there is a high degree of negative association between A and B. The value of Q lies between -1 and +1. There is a perfectly positive association between the variables. The measures of association refers to wide variety of coefficients that can be measured with the strength of relationship that exists. The strength of the relationship can be described in several ways. The word association particularly measures the strength of relationship for at least one variable with that of the other variable. The variables may be dichotomous in nature, generally nominal or ordinal in scale, which means if you keep on comparing the various data that is being given to us, then we should be in a position to calculate the measure of association. One of the finest example of testing the measure of association is the chi-square test, which we have already discussed previously. We'll keep on continuing to test the data, test further. I hope you understand and you complement by studying. Next time we discuss something else. Till then, bye bye. Thank you very much.